we've already just looked at calculating the pH of the hydronium ion. So to do that, we just find the negative log of the actual concentration of the hydronium ion. Now, what happens if we're given the pH? So what we're going to be looking at right now to wrap up the lesson is to find the concentration of something, to find the concentration of something when we're given the actual pH. So to do that, well, what's the reverse step of log? Well, we've already talked about log and how, or the logarithms, and how we were trying to find the logarithm of something, right? And it was always a base of 10. So 10 was the base to some kind of an exponent, and that exponent, in fact, is the pH. So the equation to find the concentration of the hydronium ion is equal to 10 to the power of a negative pH. So what we do is 10 is our base, right? Our logarithms, as we said, and our exponent is negative and whatever the pH value is. So let's look at it. It'll make a little more sense when we look at the first practice problem. So here's the first practice problem for these type of equations. Calculate the concentration of the hydronium ion for a solution with a pH of 4.5. So we start off with our main equation. So the concentration of the hydronium ion is equal to 10 to the power of a negative pH. So I put it in red because that's what we're going to substitute this 4.5 into. And it's going to look as follows. The concentration of the hydronium ion is equal to 10 to the exponent, or to the power of, negative 4.5. This 4.5 is the pH value from our question. So we throw that into the calculator, and we get the following answer. And this answer that we get in our calculator of 3.1623 times 10 to the power of negative 5 is our concentration of the ammonium ion in moles per liter. But now, we've got two significant digits in our question, which means we need two significant digits from our answer. So we want the 3.1. We're going to look at the number immediately following it, and the answer for this question becomes the concentration of the hydronium ion is equal to 3.2 times 10 to the power of negative 4 moles per liter. Let's look at one final sample problem dealing with the same type of question. So calculate the concentration of the hydronium ion for a solution with the pH of 10 to the power, or 10.25. So same thing. To find the concentration of the hydronium ion, it's equal to 10 to the power of negative pH. So what is the pH? 10 to the power of negative 10.25, right? This negative 10.25 from this pH value. Throw that into your calculator, and we get the following concentration for the hydronium ion in moles per liter. So the question has four significant digits, so we want the 5.623. We look at the number immediately following that, and it doesn't change anything. So the answer for this question becomes 5.623 times 10 to the power of negative 11 moles per liter.